Give me a Q. Give me a T. Give me a A. If you're a fan of this show, you know we talk a lot about secure coding, and that's because it's an important concept both in the real world and on certification exams. So today we're going to talk about a type of attack that actually exploits code that isn't written securely. So we've talked before about code injection, which is basically when a user can type something in and they type in malicious code or malicious script that's going to perform a bad action. And today we're going to talk about a specific type of code injection called SQL injection, or Sqli. That's what the cool kids call it. So what this means is we are taking advantage of a SQL database and we're performing actions that we're not supposed to. So in a SQL database, you can do a lot of different things. You can add values to your database. You can drop values from your database. SQL can also be used for authentication. So in today's example, we're going to look at how you could actually bypass authentication and log in as an admin to a SQL database just from the input field. Alright, so we have a lot of stuff on the board, but this is actually going to show us how, just by interacting from the user side of the web application, we can actually bypass authentication. So what you have to remember, the context is, we have a web application that we can actually input and type things into, and that's going to then query a backend database to perform some sort of action. And this right here is simply just the code, very simple, almost pseudocode of how it actually communicates and what's actually going on. So let's go through the process. If I'm going to try to log in, say my username is Sam, and because I'm a huge nerd, my password is a really bad password, password 1. So what happens here is I'm going to type this in, and this is going to, again, query the backend database, and this is what the code or language is actually, the syntax is going to look like. So what we're saying here is, okay, select all from this table where my login ID is Sam, and the password has to be password 1. So what's going to happen is the system, or the SQL database, is going to look through here and say, okay, is the login ID ever Sam, and is the password matched with password 1? Yep, okay. We are then authenticated, we're able to log in. So what this was right here, when it looked through and it looked for that match, that's called a true condition. And that's how SQL works, but that's also how SQL injection works. So imagine we weren't just this sort of typical user named Sam. What if we were actually a bad guy, or Sam's long lost bad brother, Cam, who actually wanted to, again, log in as an admin? How would you actually do that? Well, you would manipulate some of the syntax right here. So the first thing that you would want to do is, if you think about it, we had to create 2 true conditions. The login had to be Sam, and it had to match with the password being password. But instead of doing and, let's make our lives a little easier from the attacker perspective, and let's do an or statement. The or statement is going to allow us to say only one of these things has to be true, and then when that happens, we're going to be able to log in. So the other thing you have to think about is, okay, well, what's my syntax going to be? And in SQL, one of the things that, again, you want to be looking for is what we call a true condition. And in SQL, you have to say, okay, what is always true? So a very simple and easy and sort of very common attack is asking yourself, does 1 equal 1? Yes, that is always true at all times, right? So you, just by speaking in a language that SQL understood, basically told it, okay, 1 equals 1, so my new syntax is going to be, if we just sort of envision this being down here, and those 2 dashes are something that I don't want you to worry about too much now. That'll be for a different time for a different video. But basically what we're saying is we just created a true condition here, and it's always going to be true across all the board, and it's not really comparing anything, so it's just like a one-time instance here. So what that means is, guess what? It's going to pull everything here. It's going to actually be true for all of the user IDs. So I can then bypass authentication, and since admin is first on the list in our database, I'll be logging in as an admin. So that's a little behind the scenes of how a SQL works. Now let's take a look at how to prevent or stop this type of code injection attack. So the best way to stop a code injection attack of any kind is input validation. That means we are validating the input that the user actually types in. And a specific type of input validation is called sanitization. And that means we're actually dropping risky characters. So in this case, there's no reason a user should be able to type in this type of injection, right? So how a SQL work from the example, you know that it revolves around some of these apostrophes. So that is risky, code or risky characters, especially if we have a SQL database on the back end. We should not be accepting that at all. So we could produce an error message and make the user, type something else in, or we can do sanitization, which takes us a step further and actually drops some characters. So let me show you how it works. If a user types that in as their username, guess what? It gets sanitized. And watch what happens. That risky character actually gets dropped, and we are accepting input that's a little bit safer. So the CSSP exam just added a whole bunch of content on secure coding. In our classes, we go through these details. We show you what malicious code looks like, how an attacker could actually bypass authentication and do other things they're not supposed to by typing in malicious code and malicious script. And we also, of course, go through how to stop it. So we'll see you in class, and we'll see you next week on QTNA.